Okay, hi guys, we'll be continuing on seeing analysis of mixture. Okay, so let's say we have to calculate the weight percentage of A in a mixture which contains two substances, which is substance A and substance B. Then the weight percentage of A can be calculated with mass or weight of A present in the mixture upon or divided by weight of mass or weight of the mixture into 100. Okay, and weight fraction would be calculated as weight of A upon weight of mixture, and into 100 term would not be there because we are calculating fraction here. And one more thing, weight fraction equals mass fraction. Okay, next let us see a question wherein we have been given a 20 gram of mixture which contains 4 gram of A, 6 gram of B, and the remaining grams of C. Okay, remaining would be 20 minus weight of A and B, which is 10. So 20 minus 10 is 10 only. So mass percentage of A is, or rather A would be mass of A present in the mixture, which is 4 gram, upon weight of the mixture, which is 20 gram, into 100. Okay, similarly mass of B and mass of C can be calculated. Mass of B would be 6 upon 20 into 100, and C would be 10 upon 20 into 100. Similarly, if you have to calculate mass fraction here, then into 100 term would be missing in all the three, and only 4 upon 20, 6 upon 20, and 10 upon 20 would be there. Next, if you have to calculate next, if we have a question something like we have been given three substances in a mixture. Okay, and we have been given that in a mixture we have 10 grams of A, 25 grams of B, and 35 grams of C, and molar mass of A, B and C are also been given. Molar mass of A is 20 gram per mole, B is 50 gram per mole, and C is 140 gram per mole. So total mass of the mixture would be nothing but mass of A plus B plus C, which is 10 plus 25 plus 35, which is 70 gram. Okay, so now if you have to calculate mass percentage of B, it would be mass of B, which is present in the mixture, upon total mass of the mixture, which is 25 upon 70 into 100. Now if you have to calculate mole percentage of C, how will it be calculated? We'll see. So if you have to calculate mole percentage of C, it would be nothing but moles of C upon total moles in the of mixture into 100. Okay, so moles of C, let's calculate. Moles of C would be given mass of C in the mixture, which is 35 gram, over molar mass of C, which is 140. So it would be 0.25. Okay, similarly moles of B would be given mass of B in the mixture, which is 25 gram, and molar mass of B, which is 50. So moles of B in the mixture is 0.5. Similarly moles of A can be calculated with the same idea or same formula, that given mass of A in the mixture is 10 grams and molar mass of A in the mixture is 20 gram per mole. So I hope you know that molar mass is calculated in terms of gram per mole. Okay, so moles of A in the mixture would be 0.5. So total moles of the mixture would be moles of A plus B plus C, which is 0.5 plus 0.5 plus moles of C were 0.25. Total moles of the mixture is 1.25. Hence mole percentage of C would be moles of C present in the mixture upon total moles in the mixture, which is 1.25. So into 100. So mole percentage of C would be 20%. Now let's see another question wherein we have been given that, or rather we have to calculate percentage of each component or of each atom in this compound, which is C6H12O6. So we have seen in the past lecture that mass percentage equals weight percentage, which in turn equals component percentage. So component percentage would be nothing but mass percentage or atomic mass percentage present in this of a particular atom present in this compound. So for this compound we can calculate that the atomic mass of calcium is rather carbon is 12, and number of atoms of carbon in this compound is 6, upon total weight of or the total molecular weight of the compound would be 180. You can calculate with 12 into 6 plus 1 into 12 plus 6 into 16. Okay, or rather 16 into 6. Okay, 16 into 6, this would give you 180. So this is the molecular weight of the compound. Okay, so it would give you 180. Okay, so percentage component of C would be 12 into 6, which is the total number of atoms present of total number of carbon atoms present in this molecule. So it would be 12 into 6 upon 180 into 100, it would be 40%. Similarly, for calculating component percentage of oxygen, we will be taking atomic mass of oxygen, which is 16, multiplying it with number of oxygen atoms, which is 6, divided by 180 into 100, that would give us 53.33%. Similarly, for calculating the percentage components of H in the mixture, we'll be taking the atomic mass of one hydrogen atom, which is 1, and how many number of hydrogen atoms are present in this compound or a molecule, which is 12 upon 180 into 100, which will give us 6.66%. Okay, next let's have this question wherein in a mixture you have 2 moles of hydrogen and 1 mole of oxygen. So if you have been asked to calculate the mole percentage of hydrogen, it would be moles of hydrogen present in the mixture upon total moles, which is 2 plus 1, that is 3 into 100. This is the mole percentage of hydrogen in the mixture. Next, if you have been asked to calculate the weight percentage or mass percentage of hydrogen in the mixture, it would be, so 1 mole of hydrogen weighs, the atomic mass of hydrogen is 2 AMU. I am not talking about the hydrogen atom, I am talking about the hydrogen molecule. This is the weight for 1 mole. So for 2 mole it would be 2 into 2, which is 4 AMU. Or rather, I am not writing any unit, it is understood that we have total molecular weight of hydrogen, or rather 2 moles of hydrogen would be 4. Similarly, for 1 mole of oxygen, the weight would be 32. Okay, so the weight percentage or mass percentage of hydrogen in the mixture would be 4 upon 4 plus 32 into 100. Okay, so the mass percentage, you can write that molar mass of hydrogen is 2 gram per mole. Okay, and when the moles are 2, it would be 4 grams. Okay, so 4, this is molar mass of hydrogen and this is molar mass of oxygen. So same method or same formula can be applied here also to calculate the mass percentage of H2. Now suppose we have a question like this, that the atomic mass of boron is found in the nature to be 10.8 AMU, and the nature or sample contains only 2 isotopes of boron, which is having atomic weight 10 and having atomic weight of 11. So let's say we have 100 moles in the mixture with X moles of boron 10 and remaining 100 minus X moles of boron 11. So we have to calculate the value of X, wherein the atomic weight of boron 10 would be 10 multiplied by the number of moles of B10, which is X, and the atomic weight of boron 11 would be 11 multiplied by the number of moles of B11 would be 100 minus X upon total moles of the mixture, which is 100. It gives 10.8. So just simplifying it, so 10x plus 1100 minus 11x gives, this goes to have a cross multiplication with 10.8, it gives 1080. So X comes out to be 20%, or in other words we can say that the moles of B10 found in the mixture were 20. Okay, so next let's see the generic formula for calculating questions similar to the above discussed question. So atomic mass of an element is the total mass of all the isotopes upon total number of moles of that element. So in mathematical terms we can write it as summation of MIXI over summation of XI, where XI is the mole percentage of ith isotope. Okay, now on the same formula we are discussing an example. So let's say in nature we have Cl35 present in 75% molar ratio and Cl37 present in 25% molar ratio. So we have to calculate the atomic mass of Cl. So atomic mass of Cl can be calculated with total mass of all isotopes, which is 75 into 35 plus 25 into 37. So this is the total mass of all isotopes divided by total number of moles, which is 100. Okay, so this gives the atomic mass of chlorine as 35.5. Now let's discuss another question on the same lines, that suppose we have a neon, which is neon mixture, which is having 91.8 percentage of Ne20, 0.5 percentage of Ne21 and 7.7 percentage of Ne77. Okay, so we have to calculate the atomic mass or molar mass of neon rather. Okay, so we can just have this like 91.8 multiplied by 20 would be the mass of means the total mass of Ne20, plus similarly for calculating overall total mass of Ne21 we have to multiply 0.5 with 21, similarly 7.7 with 22. Again, total number of moles in the mixture is 100, so this can give you the molar weight or atomic mass of molar mass of neon in the mixture. Okay, so with this we come to an end of this lecture. In the next lecture we'll be discussing some more examples and we'll be seeing some more theory on stoichiometry or stoichiometry. Okay, so till then, good luck and goodbye.